Everybody, welcome to the Curious is Better podcast. I'm Craig Lamb with Invative. Today I have Jon Williams from Viridi. He has some really interesting technology. You have heavy equipment with electric power, and I'd really like to hear the inception story. Tell me how you got started.
Yeah, I mean, Craig, look, thanks for having me on. It's always fun to do this and talking about what you do. You always learn something both ways. So, look, Viridi started as a kind of a bet, I would call it, or a why can't we do this, or more to your tagline, curious is better. So we were curious as to how we could do this if it would work, and we kind of went down that road. Company started electrifying small construction equipment. So the category is called compact construction equipment. It's anything under 8 tons, and we started with a 4-ton excavator. We called it Frankenstein at the time because it looked like something out of Junkyard Wars. If you've ever saw that show,
Oh
it
yeah.
had a lot of wires and straps and funny things welded to it, but it worked. Kind of initial project led us to really a concept of battery safety because if you look at the evolution of EVs, the entire engineering and design parameter has been eliminate range anxiety. Right? We want EVs to go farther, and we want to be able to charge them very quickly. And if we can go 500 miles and we can charge them in 20 minutes, it comes very close to replicating what an internal combustion engine does. As humans, we don't want to change our behavior. So we want something new and better, but we don't want to give up convenience or optionality that we had in the previous product.
Right, but while you were prototyping, you had like an exceptional challenge, right? Weren't you? Didn't you prepare for a demo with like National Grid, and you had to have a zero fail battery
We,
pack,
we did,
right?
yeah. So we had the chairman of National Grid from the UK coming in to witness this thing that we had invented without ever telling us. And we had like a 3-month window to go from Frankenstein to an operating machine. And we did that. Like, it was a bit of a hassle, but our teams in the other companies that I own are very adaptive and very creative, and they're very good at what they do. So
I mean, you're understating. I think but you had to destroy like millions of dollars during R&D, right? Trying trial and error, trial and error, trial and error. Like,
yeah,
what's
so
that
that
feel like?
happened, right? That happened as we move forward, right? So we did this demonstration for National Grid. The chairman thought it was incredible, and he's like, "Look, let's go down this road." But really, what that road showed us is that nobody was building a safe battery system. They were building a very energy dense, very light battery system to address the EV requirement of range. Now, internal combustion engines and cars light on fire sometimes. You've seen videos of a car on the
Sure.
side of the road burning, and battery cars light on fire sometimes, and we see videos of them burning. The difference is that a battery fire you can't put out. You can only let the energy consume itself, and when it consumes itself, it'll stop. But there's no putting it out. And as we bring those vehicles into our lives and we put them in garages and we put them in parking ramps and we put them in places where we can't have an uncontrollable fire, you create a lot of issues. So I looked at this and our team looked at it and said, look, if we're going to put batteries in construction equipment and construction equipment's going to be in a chemical plant, we can't cause a failure in a chemical plant. We can't have an uncontrollable fire light off a chemical plant. We can't go into an automotive facility with an electric machine that has no emissions, but we light the production line on fire. That doesn't work, right? It's not a better product. So the question became, how do we solve for that? Is that possible? And in that question of the possible, the journey began. And Craig, you mentioned how much stuff did you destroy? We destroyed $5 million worth of battery product.
Yeah,
Getting
but
to a
you also touched. You were talking about your team though, John, right? So I can only imagine the diversity in that what that team looks like, right? You have to have like academics and then ops guys, right? That are and like for usability and all this other stuff to be able to create a product like that. So like culturally, how do you balance? Because they're very different types of people. I mean, even in our engineering team, right? We have our introverted, like extensive logical thinkers, and then we have the efficient coder. Like what's your at least recollection of ramping up that kind of culture?
Like, I mean, Greg, it really is like if you have really smart, really capable people in their field, when they get out of their field, they tend to get a little nervous, right? So when you push somebody who's very good at engineering and discipline into something that's less defined and more subjective, they get nervous. And the way you bridge that is really with just leadership. You give them the confidence to say, look, it's okay to make a mistake. It's okay to fail. I don't need you to be perfect, but I need you to use all your talents and all your expertise to get as close to perfect as we can. And if it all goes bang, it's okay. throw it away, start over. And that's really like my role in this is not to be the engineer. It's not to be the genius that invents this. It's really to say to those very smart, capable people, I have your back, right? So when you go down a road and it doesn't go anywhere, it's okay. Pull everything back, start over, let's do it again. By the same token, I don't need to analyze something to death. Like if we make a mistake, just let it go. Get as much information as you can for the next one and start over. And that was, that was interesting because, we have fabricators and heavy, I call them heavy metal people that build stuff out of very heavy structural steel every day. And then you have physicists and MIT PhDs that are like, well, I want to engineer this down to the, to the millimeter. Like
Sure.
if you need a 20 millimeter steel, I don't want to use 21. Well, I would say to them, look, if 1/8-inch steel didn't work, let's go to 1/2 inch. And they're like, well, we don't need 1/2 inch. I go, I know. The cost difference between 1/8 and 1/2 isn't going to change the product. Just
Right.
double
And
up.
you're at a production released version, right? Of your product.
Well, so look at our products were at the Jazz Festival in Rochester last weekend, right? Powering the Jazz Festival without using diesel fuel. So there is plus or minus 80 megawatt hours of battery systems across the US right now and Canada that are running every day in every conceivable application you can imagine. We just did Live Nation concert on Governor's Island in New York City. We were
That's
the first mobile battery system that the New York City Fire Department approved to be used in a public event. So yeah,
that's amazing. That's an
we're running.
amazing accomplishment for sure. Well, so now that it's up and running, and I don't know if you want to spend a little time talking about how the control system. So I imagine that's got a lot to do with when they're evaluating the product, right? Where it can be and how it's controlled and how it works and things like that. What's the next step? Like, where's the roadmap of evolution? Like, what will you be?
Yes. So look at any product that is going to have traction or be widely used in today's economy. The hardware of the product is really important, but the software and an ability to remotely control and access and adapt the product is way more important than the hardware.
Right? We talked about that.
We are a remotely connected world, and it's becoming more so. And as AI develops, being able to push and pull information from a device and let that device adapt to the current situation, it's not just important. You can't have a product that doesn't do that. So we have the best battery hardware in the world today. It's the safest, most energy dense, most flexible hardware ever created. We've combined that with what I think is probably, at least in the US, the most flexible, safe, and secure connection technology that is in the market. We can push and pull software, we can push and pull signals, we can customize parameters, we can read data coming and going, we can put geofences around product. Like for New York City Fire Department, we're going to give them a customized screen that shows every device running at any time, and it'll send them an alert if anything is happening around that device that they need to know about. So even though our device might not have an issue, it'll sense if something's going on that it has access to.
Yeah, so we talked about this a little bit too. You've integrated. Remind me though, because I might be off. But you integrated different IoT devices for that very purpose, right?
Yeah, so look, this is a group of engineers that came out of our IT, right? Something near and dear to your
Oh yeah, it's our whole
your
staff.
pedigree. And what they did was they were solving an issue with military technology for the grid in California. So they were building a device that would go onto the transmission system in California, and it would read wind, temperature, voltage, resistance, heat. Even if a bird landed on the wire, it would know it. So it took in all these inputs, and then it would calculate on the device a solution for the grid operator to say, you can move more power through this line, even though, right, the system is showing the lines at capacity, or the line's about to overheat, you better back down on transmission, because even though the system's not showing it to you, in real time, we're here, and this is what's going on. So it was a very advanced device. It went through FERC, and it went through every security protocol in the nation, including Homeland Security. Cal Edison decided not to use it. Right. It's just one of those things, right? They had hardware from another provider. The other provider probably had better salespeople, and they convinced the utility that you don't need to change. We were introduced to this device through an investor, actually through Tom Golisano, who was an investor in us. and also had a position in that company. And, Tom's people said, you need to look at this because we think it's really interesting for what you're doing. And frankly, Craig, we all like to think we're geniuses. We're only as good as the information we have.
That's right.
And having an investor like Tom's office, like Dave Benzie and Dan DeBofi run his office, and Matt, they're just very connected into a lot of different areas, and they're very involved with that. What they'll do is say, look, here's 10 ideas we have. We don't know if they're good or bad, but we want you to be exposed to it. Well, in this case, if we hadn't have been introduced to this technology, we would have had this really great battery hardware that wasn't really functional in the economy.
Yeah. So even though it didn't work out, it was a catalyst for inspiration. So what?
It didn't work out for Cal Edison, but it was perfect for us.
Yes.
Everything. So if you think about this, right? I mean, energy is at the intersection of everything in our economy today.
Oh, right.
Okay. And what do you need? You need resiliency. You need capacity. You need a distributed system because the grid's not going to support what we're doing. And you need cost effectiveness. Now, if you had all four of those, but it wasn't safe, screw it. Right. We're not going to put something that's not safe into our daycare centers, our commercial buildings, our homes, our industrial facilities. So we led with safety, and then we solved for those other four things. And the software team today is looking at every customer application and saying, what are the unique inputs and metrics that you need to optimize your energy profile? How do we bring down your cost, improve your resiliency, and ensure that all your electronic devices have consistent voltage and consistent wattage, right? So you don't want peaks or valleys in your power supply.
I imagine they're using some AI models too to help with that.
Absolutely.
Right? Because the training data has got to be, you got to have a ton of training data already. And that will reveal so much as far as just the nuance in these efficiencies, right? Those thin lines.
I mean, if you think about it, right? I mean, Elon Musk is developing a self-driving model based on the data that came in from every car he sold in the last 10 years. We're going to build essentially a self-driving energy model based on all the data that we're taking in from our customers, because we're going to know before they do what their energy is going to look like. We're going to know when they hit a peak. We're going to know when they have valleys. We're going to know when the system has excess capacity. We're going to know when they need more resiliency based on weather data.
And John, how huge is that? And if even like in mid-sized cities, right? Like when you talk about the stress on the grid at 8 a.m., people get to the offices and then all these commercial buildings light up, right? Wow.
Craig, think about this. Right, here's the metric to use. Every day, we generate 10 units of energy. We transmit 10 units of energy. We distribute 10 units of energy, but we only purchase through the meter 3. So we make 10 and we buy 3. If you put my packs behind the meter, you can buy 8. I can 2.5, by 250%, I can increase the available energy to a customer today without a wire, without transmitting, without generating, without doing anything. Just by putting packs behind the meter, we can 2.5 times, like 2.5x, we can increase the units of energy that are sold through the existing grid. And what does that do? Brings down the cost to everybody because you increase utilization significantly. You add resiliency. You don't mow down farm fields. You don't put up transmission lines across somebody's backyard. You don't fight with everybody about what you're trying to do. And you don't spend hundreds of billions of dollars on hardware that's not going to fix the problem. The problem's not, do we have energy? The problem is we built a system that had no storage. Why does our fossil system work so well? Our fossil system works because we have storage throughout the whole system. We store it in the ground in Saudi Arabia. We store it in tankers as it comes across. We put it in ports. We have gas tanks under every station. We have storage at every step of the system. But our electric system was always an on-demand, right? If a generator failed, the lights went out. Well, when you add storage, that doesn't happen anymore.
I know, but just academically talking about electricity storage, it seems like a misnomer, right? Because it has to constantly be moving, and I don't have the academic background to explain that.
But it doesn't. Like all my battery pack is it's a very sophisticated can of gas. It's a sophisticated storage device for energy units.
Yeah, right? That's incredible.
What's a 500-gallon fuel tank? It's a dumb storage device for energy.
That's right. So I am curious, John, what do you think the future of energy is going to look like based on all the work that you're doing and your roadmap? Like, do you think that we're going to be able to get?
This is the largest unaddressed market that's ever existed in humankind, because before this is done, every single outlet in every single building is going to have storage on it, and it's good, and it's our energy is going to be way more resilient. Lights are never going to go out. We're going to be able to expand all of this electronic economic development that we've been kind of restrained on, and it's going to be cheaper. I mean, it has to be better. Like we can't sell something that is worse than what we currently have. So it's got to be cleaner, it's got to be less expensive, it's got to be safer, and it's got to be more resilient.
All right, let's. I want to just get, because I just think that your moxie, I guess, for picking a cleaner term for the word, is that someone addresses you with a bar bet. You go, yeah, we can do that, and you tackle all of these incredibly technical obstacles, clear them, advance it. You have it working, and you're gaining information over and over, and you're laying out a roadmap for I would say like a clean energy path, right, for everyone. That's a rare find in a person to have that kind of moxie and using technology and innovation to serve that. What advice would you give any other business leaders as far as when you're faced with innovation or I don't want to say the bet, but like the challenge of innovating and then really understanding and appreciating what that really means? Because you've summarized in like 15, 20 minutes this road that is much longer and windier and rockier, than you can just euphemistically describe, right? There's a fitness to that. It's like, how do you communicate to someone else? It's like, this is how it's going to go. And that this is the award, but this is how it's going to go.
I mean, Craig, look at your podcast is curious is better, right? So Walt Whitman, what's one of Walt Whitman's greatest quotes, right? Be curious, not judgmental, right?
Right.
And all he's saying in that statement is intellectual curiosity should not be restrained by arrogance, right? Don't believe that we have all the answers. Don't believe that what we're doing today is somehow the playbook. Just, be curious. And when stuff comes at you, don't be afraid to rely on other people for answers, right? I mean, we all like to think that we know it all, but we don't. And, you don't know what you don't know, right? That's one of the famous lines. Look, I've been incredibly fortunate to have really smart, capable people around me, from investors to people that work with me to people I have professional relationships with. And in listening, and to your point, having a little moxie, look at the beauty of our economy is, and nobody says this enough, Greg, if you completely screw up and you fail at everything you do and the whole thing comes apart and the wheels come off the cart, you go broke. But guess what? You don't go to jail if you go broke.
Yeah. You don't die. You don't go to jail.
They essentially wipe your slate clean financially and you get to start over. So what's the worst that happens in that exercise? Like, it's not like this is life and death stuff, right? This should be fun. Now, it's called work because it's not vacation. It's maddening. It takes all your energy. You got to commit to it with everything you have. But if you get there, or if you don't get there, there's a lot to be learned, and you will find something in that journey. So don't worry about being Einstein. Don't worry about kind of being Tesla and figuring out electrons. Just look at something that you have exposure to and fix it. And if it takes 10 units to get it done today, just say to yourself, how can I do it with 7 units? And if you do it with 7 units, the 3 that you saved, you're going to put in your pocket.
I think that's good advice. I mean, what a gift it'd be to be an engineer on your team, because it just you're just the way that your mind works as far as understanding the road to actually make breakthroughs and innovate. I think it is a philosophy that could be shared. I appreciate that. Jon, I want to thank you for joining the podcast. I appreciate it very, very much. I look forward to speaking with you again in the future. And I want to just say thanks. Appreciate it very, very much.
Well, it was fun. Thanks for having me on.